early experience, it is only within the last century, from 1900 up to this point, to 2000, right, that we have come to appreciate how important early experience is. It is also only recently, at the turn of the century, that we have begun to recognize in how many ways our psychological and physical beings are affected by the amount and quality of our early experience. Example, Freud. Freud wrote many papers at the turn of the century indicating that personality development is the product of one's childhood. And Freud wrote that, it's a famous quote from him: the child is the father of the man. Meaning, if you want to understand adult personality, look at the child of the man. Look at the man when he was a child. Right? And this statement spawned the birth of developmental psychology. So you see here, Freud postulated the psychosexual development. Say everything propelled by sex. So he was at that time still called the dirtiest old man in psychology. Everything associated with sex is dirty. Anyway, that's what human conception of sex, which is actually a good thing. All right. So we then began to the psychologists began to look into developmental psychology. Anyway, so there is no use to talk about the nature-nurture controversy as it remained unresolved for decades, for so many years. Even at this point in time, the debate goes on. All right? Now, there's no need to talk about that, because the issue was approached with cherished beliefs and narrow-mindedness. The issue was stated as an either-or proposition, either this or that. No middle ground approach. No middle ground approach. So the hereditarians, I mentioned the hereditarians emphasized heredity at the expense of environment, and vice versa. The environmentalists emphasized environment at the expense of heredity. Neither side fully recognized the importance of the fourth dimension. That is critical time period. Critical. All right. So development, we have to recognize that development is a result of heredity interacting with time, interacting with environment, heredity interacting with environment, interacting with time. All right. So we have to look at time. The critical time critical time studies. Let's take a look at this. The critical period, critical time studies. So psychologists have found that most behaviors could best be learned within the critical period, a period that promotes optimal learning. Now, behaviors due to evolution are not influenced very much by the environment or a special practice. For example, the phylogenetic activities such as creeping, the infant creeping, grasping object, or even walking. As you will see later on, I will talk about this a bit more. But anyway, let's talk about it a little bit now. Is that there is no point in prodding the baby to walk earlier, because walking is phylogenetic, and there is no way you could speed it up. But then when the time comes, that's determined by our DNA, by genetic. When the time comes, the baby will get up and walk. No matter what, even if the baby falls, and the baby would be very consistent. Would get up and walk again, fall. Okay, the baby will fall, get up and walk again. So that's phylogenetic, propelled by what? By genetic disposition. All right. So critical periods occur when rapid organization of some kind is going on within the individual. Okay, so critical period has been defined by what? By John P. Scott. All right. You will find that his name is also included in IQ. Anyway, at a time when a large effect can be produced by a smaller change in conditions than in any later or earlier period of time in life. That is to say, during the critical period, any given activity is most susceptible to modification through repetition or simply through performance. Okay, a post-hoc definition. Right? This is what a post-hoc definition. Those of you who have taken my design 1 and 2 courses, you probably understand what that is. But anyway, so it does not predict what we need some hard data to indicate precisely when the various critical periods occur. Okay, so we cannot predict, because different people have a different genetic disposition. Like some of us could walk at 10 months old, start walking at 10 months old, some 12, some much later. Is that right? Some much later. So you see what you see here. We cannot predict with precision, but we know approximately through so many studies. Okay, it has also been suggested that like I just mentioned, critical periods occur when rapid organization of some kind is going on within the individual. So this definition has some predictive power. Is that right? This one has some predictive power. So a great deal of research remains to be done in this important area. At this point, there are few hard data to indicate precisely when the various critical periods occur. We do know, however, that the critical periods generally coincide with periods of most rapid growth. So that is to say, there must be changes taking place within the organism which are what correlated with time, and hence what account for the existence of critical periods. Right? So what we have, for example, language. Okay, we know that the critical period for picking up a language will be between the age of 2 and 5. Within this age range, we human beings could pick up many different languages if we have consistent exposure to those languages. All right. So let's take a look at some observations and theories of early experience. Now, look at a landmark study by Nancy Bailey, beginning in 1929. She began a longitudinal study of human growth and development called the Berkeley Growth Study. So look at that early 1929. Okay, she found the following: IQ, intelligence quotient. Let's say this is a score. Okay, and I will explain in due time. Okay, let's say the score. Okay, it's an IQ score, and I can tell you now that 100 is the mean for white subjects. Okay, based on huge amount of data. Okay, we know this is true. Anyway, her findings. First, IQs are not constant. Okay, IQs are not constant. That's to say, one's IQ score is not fixed at birth, but is instead a human quality that ebbs and flows as a result of environmental circumstances, and of course as a result of the person's interaction with the environment. Now, second, IQ variability is greatest during the first 5 to 6 years of life. So the older the child, the greater the IQ stability. So that is to say, for the first 5 to 6 years, we experience, like the child experiences, rapid IQ growth. Afterward, the growth is a lot slower. It's a lot slower. I will show you the growth curve later on. Okay, the first 5 to 6 years, the growth is rather steep. It's steep, okay, like this, and then later on it will plateau and level off. Okay, something like that. I will show you later on. Okay, number three, intellectual ability may continue to grow throughout life. May. It depends on the person's encounter with the environment. Okay. Now, so whether an individual's intellectual growth, whether it grows or declines, seems to be a function of environmental stimulation. For example, if a person was working in assembly line, or just packing groceries in a supermarket, they are less able to experience intellectual growth than someone who works in areas requiring somewhat strenuous mental exercise. Okay, So this is true, is that right? This is true. Now, number 4, the components of what? Intellectual, the components of intellect, okay? The components of intellect change with age. So that is, the intellectual development in childhood occurs in qualitatively different stages. The quality of intelligence differs among the stages, as you will see when we discuss what Piaget's cognitive development. So what you will see that this is the case. Now let's take a look at the growth curve, or this is also called the intellectual developmental curve, and it is what also what a curve we call learning curve. Okay, let's see what it looks like. After reviewing virtually all the studies on intellectual growth, at that time 1964, okay, Benjamin Bloom, and you will encounter this name again and again, okay? Benjamin Bloom plots this curve here called the negatively accelerated growth curve for intellectual development as well as for learning. Okay, now look at this here on the vertical axis. It is say intellectual development, say for IQ. Then we have age horizontally. Okay, age horizontally. Now look at this here. For the first 5 to 6 years, the growth is very rapid. Then it levels off. Okay, it levels off. But then, of course, the curve still increases, going up. The curve goes up, but then slowly, depending on our encounter with the environment. Okay, now with increasing age, there is the decreasingly positive effect from a beneficial environment. Okay, that's to say, as we get older, we find that it is a lot harder for us to learn new stuff. Right? So the curve is true for human intellectual development as well as for human learning. Initial practice and experiences are extremely important. Okay? So the importance of practice is also observed in the serial position learning curve in memory. When we come to memory, you will see the serial position learning curve. Okay, sometimes from those curves we can we understand how we grow in terms of intelligence. Okay. All right. So with increasing age, there's a decreasingly positive effect from a beneficial environment. So that is to say, younger children, 3-year-old, let's say, younger children profit far more from enriching experiences than older children, like 7 or 8-year-olds. Right? So Benjamin Bloom, he argues that beneficial early experience is absolutely essential for cognitive growth. So you see here, if you look at the graph here, almost 2/3 of our ultimate cognitive ability is formed by the time we are 6 years old, 5 to 6 years old. Okay? Bloom asserts that experience has its most profound effect very early in life, during the period of most rapid growth. So essentially, Bloom's findings pointed to the importance of critical periods for learning when rapid organization of some kind is going on within the individual at the early age. It must also be pointed out that, however, that the child is not a passive recipient of stimulation. The child's eyes and ears seek to feed upon a rich variety of input. So that is to say, the environmental encounters are important. And also, the environment must be shifting or changing for new stimulation to occur. All right, so let's take a look at a very important notion called stimulus variety by Hunt. Okay, so stimulus variety as the basic ingredient of intellectual development. So take a look at this, at Hunt's theory. Hunt was 1969, very early on, but we still use his theory. Okay, Hunt insists that the crucial ingredient in intellectual development is stimulus variety, or stimulus heterogeneity. That is to say, the more the child hears, sees, and touches, the more the child will want to hear, to see, to touch, and more intellectual growth will occur. Okay? So, in sum, crucial ingredient in intellectual growth will be variety of stimuli, a shifting environment. Therefore, a shifting environment providing stimulus heterogeneity as opposed to homogeneity. Okay, so a changing environment will provide different stimulations to the brain. However, Hunt wants that the child should not be overwhelmed with stimulus variety. Okay, the variety of inputs must somehow be matched with the child's present growth. And when we talk about when we come to Piaget's intellectual stage theory, and we will further learn what that means. Okay, by an approach by the matching. Okay, matching. Okay, Hunt also talks about this. Okay, as you will see later on. Okay, so Hunt insists that there is a point of stimulus variety that children naturally seek. So indeed, we all seek optimal level of arousal. Too much arousal, we withdraw in frustration. Too little, we withdraw in boredom. Is that right? So the famous psychologist Berline, he proposed the optimal arousal theory. Right? So, for example, adolescents, when they are bored, they resort to taking drugs. Okay? Emptiness inside, therefore seeking arousal from outside. Right? So it is important that do not let teenagers or adolescents, do not let them get bored, to occupy them. Okay? It has also been shown that early stimulus deprivation damages both later intellectual development and later motor development. Okay? It is what many studies, okay, demonstrated that. So Dennis in 1960 showed that stimulus-deprived children who had complete motor freedom were also physically retarded. Okay, so Dennis observed what children, if I remember the experiment correctly, children what who grew up in dark cages in the mountain, later on they were retrieved from the uh, from the caves, not cages, caves, the mountain caves. Okay, but then they were because of what? Because of inside the cave, not much light. Okay, they were they had complete motor freedom, but they are what they were physically retarded. However, the reverse is not true. That is, when physical movements were inhibited only, while the eyes and ears could receive a variety of input, later motor development was not much affected. Okay, now in what? Let's say in Asia, in China, Indonesia, Vietnam, all those places, mothers in the what we call it the battle time, or the mother used to have something like a bag we carry, the back sack, okay, carry the baby in the mother's back, and the mother went about working the whole day. So the baby didn't get a chance to exercise or to walk about, okay, but then the baby could feast upon the environment, the eyes, the ear, the nose, all that, okay, and and those babies experienced no difficulty in terms of physical growth and also intellectual growth. Okay, so it is important, therefore, the baby's five senses, okay, vision, smell, taste, hearing, and touch. Okay, five senses, to be able to have opportunities to exercise or to stimulate the five senses. Okay, so this is important. All right, so let's take a look at some biological basis of early experience. Okay, now HEP in 1949, I believe is in McGill, noted that there were significant differences among organisms in the proportion of association and sensory areas. So he calls it the AS ratio. Okay, AS ratio. Okay. So the association at the top, sensory at the bottom. So he calls it the AS ratio within the brain. For example, a lower organism such as a rat has fewer association areas and more sensory areas. Therefore, the rat is more responsive to the stimuli in the environment than is human. Okay. Now, let's see here. Rats respond impulsively to every minute environmental change. Human beings, we don't. Right? Rats, when the rat hears something, the rat will turn. We don't do that, okay? But then Rats have been shown to do that repeatedly, okay? So they are They are kind of stimulus bound, right? Stimulus bound. Anyway, so let's take a look at what HAPS theory, okay, is what HAPS is very good, okay. Environmental environmental stimulation here will what affect what the individual's brain cells. Now, at that time, individuals what the individual brain cell, each one of them were unorganized. So all of the brain cells were not organized. But upon environmental stimulation, then what they become organized. So when cells are organized, they form. Okay, they are called what? Cell assembly. Cell assembly. Those cells, those nerve cells or the brain cells, they are what? Organized. Okay, they are organized. So when they are organized, then what? That means what? Learning has occurred. Is that right? Learning has occurred. And when a series of cell assemblies, they form. Okay, they form like the brain cells. They were upon environmental stimulation, they become organized and they form. They stick together, called cell assembly. And when a series of cell assemblies here and here, okay, they work together, then it is called what? Phase sequences. That is to say, a larger organization takes place. Those were cell assemblies. They begin to be associated with one another. Okay, so that's called what? Phase sequences. Okay, so a larger organization takes place. And then what? Then even more learning. So that is to say what? The phase sequences begin acting in concert with one another. So therefore, widespread organization of the brain occurs. So the child is now capable of extremely rapid learning. Okay, so all in all here, environmental stimulation will what? Organize what? The brain cell, like the brain cell being stimulated. They are organized, so they form what? They form cell assembly. They form cell assembly, and and therefore what? With more cell assemblies, more new learning, then what? When what? A cluster of cell assemblies, they form together, a larger organization what takes place. And then what? When cell assemblies, they are organized with one another, it's called phase sequences. Phase sequences, then you have one phase sequence here, another one here. They are associated with one another, so more learning, right? So that's the what? This is perhaps what? The biological basis of early experience, right? So he postulated that. Now, the human brain with larger what? AS ratio, well, larger because what? It has greater number of association area, is capable of what? Far more different varieties of learning than a rat brain. And also, the relatively small sensory areas, okay, sensory areas for human, okay, frees human from being stimulus bound. So we are less apt to respond impulsively to every minute environmental change. It also means that as the AS ratio, A over S, right, AS ratio increases, the developmental importance of pronounced stimulus heterogeneity also increases. Okay, also increases. Therefore, the larger number of association areas can feast on a variety of stimuli. Right? So Hebb saw human brain as unorganized and capable of only relatively simple forms of learning during infancy and early childhood. Then as the child experiences more and more environmental stimulation, the brain slowly becomes organized. A group of neurons begin to work as a unit. That's to say, the brain cells begin to take on a function. So Hebb called this organized pattern of brain cells a cell assembly. Right? So with the formation of a variety of cell assemblies, new learning takes place more quickly. As this process continues, as more cell assemblies are formed, a larger organization takes place. Okay, so I'm trying to summarize whatever I have just said here. Now, with the formation of a variety of cell assemblies, new learning takes place more quickly. As this process continues, as more cell assemblies are formed, a larger organization takes place. Okay? Now, when a series of cell assemblies, phase sequences are formed, so finally, as the phase sequence begins acting in concert, widespread organization of the brain will result. And the child is now the child is now capable of very rapid learning. Right? So, Hebb compared with rats raised in impoverished environment of laboratory cages with rats raised in the home as pets. As I say, all those rats raised at home as pets receive a variety of stimuli in an enriched environment. And he found that the home-reared animals superior in running a maze at that time is called the Hebb-Williams maze, okay? A form of animal IQ test, a form of animal IQ test. All right, and you know that recent neuroscience research studies in all over the world and also at Nipissing give impeccably strong support to Hebb findings. So all the world labs have now provided indisputable evidence that Hebb's theory, in general, Hebb's theory is correct. So Hebb at that time was certain that the result would be precisely the same at the human level. Well, he worked with rats, okay? And he was certain that it's the same at the human level. Enriched environment is essential for intellectual growth. Okay? All right. So biological evidence. Let's take a look. Crash. In 1969, here is sought to find out whether environmental manipulation might bring about changes in the chemistry of the brain. Now, and even at this point in time neuroscience labs, okay, in our neuroscience labs too, we are doing exactly this here. Now, look at the early biological evidence. Crash, okay, 1969, so look at this experiment, okay, selected 12 pairs of rat twins and randomly assigned them to two groups. All of them had the same diet. Okay, see here, with one group to the stimulating environment and another group in environment of extreme stimulus homogeneity. So after 3 months, the brains were analyzed morphologically and chemically. Take a look at the result. Okay, stimulating environment. In a stimulating environment, the animals lived in a cage equipped with ladders, running wheels, and other rat toys. Wow, you know what I mean, okay? All those and some labs even provide those rats with a small swimming pool, okay, very shallow. Okay? For 30 minutes each day, they were let out of their cages and allowed to explore new territory. So in general, they received a rich and varied array of stimulus input. Okay. Then what? Then you see that here the environmental of extreme stimulus homogeneity. What does that mean? The animals lived alone in dimly lit cages, rarely handled, never allowed to explore areas outside the cages, inside the cage. So that is what was stimulus deprivation. Of course, after 3 months, the rats were sacrificed. The brains were analyzed morphologically and chemically. So the brains of the enriched rats were chemically and structurally different from the brains of their siblings, of those suffering, okay, from extreme stimulus homogeneity. Let's take a look at the result. The cortex was the gray matter. It was larger, deeper, and heavier in the stimulated rats. This increase in brain size was due to an increased number of the glial cells, those responsible for memory traces, an increased size of the cell bodies and their nuclei. Okay, an increase in the diameter of the blood vessels supplying the cortex. So chemically, the brains are also different in terms of the structure. Okay? Now, the brains of enriched animals showed greater quantity of an important enzyme that readies the nerve cells for further neurotransmission. So you see here, chemically and also structurally, the two brains are different. Okay? So therefore, Crash has demonstrated that providing stimulus and response variety during the early life of these animals caused chemical and structural changes in the brains. In a very real sense, Crash might have identified some of the physiological correlates of Hebb's construct, just to prove what Hebb's construct. Right? So that is very nice. Okay, let's take a look at. Hold on. the environmental stimulation for physiological development. Let's take a look at this thing here now here. But then, unlike creeping, grasping, and walking, the nervous system and the perceptual apparatus do not mature automatically according to some preset internal clock. Environmental stimulation is needed for their development, okay, as you will see in this experiment. Anyway, the dendrites, in the cell, the dendrites, they wither away, all those tiny little spines, okay? They wither away and finally disappear if synapses do not occur there. That is to say, if the brain is not stimulated, the axon is connected to the dendrites, and you have what the dendrite is, that here is the nucleus of the cell, and the axon, and so on, right? And sensory apparatus must be stimulated by the environment in order to develop properly. Say neurons, for example, neurons on the retina of the eye may become damaged unless they are given visual stimulation. Okay? That is to say, the ganglion cells, which are responsible for vision, degenerate if they are not stimulated for a long period of time. Research studies have found that 12 weeks, if you stay in a very dark environment continually for 12 weeks, you will become blind. Something like that. Okay. Now, take a look at the Head Start program. Okay, what is Head Start? Okay, which began in the United States in 1965 by five professors. Okay, came up with the idea. One of them, Dr. Leslie McClain, he taught me when I was at the U of T PhD program. Okay, so this is called the Early Childhood Education, the Head Start program. So what is it here? For 2.5 hours each morning for the 3 or 4 years old only. Okay? So before they entered the school. All right, let's take a look at early childhood. Improved IQ scores if you give them a head start. Okay? For 2.5 hours each morning, all those kids, okay, 3 or 4 years old, they came to the school and they mostly play. But then of course here, those play, like how to play with toys, how to play with this, and then they play games together, and all of this they were carefully thought of by the 5 professors. Okay, now then the result? Improved IQ scores. And then when they entered elementary school, and they were observed to have better scholastic placement, okay? Fewer children in special education, and improved academic achievement. And so this is a longitudinal study, okay? Followed them for 15 or more years, okay? Adolescents, when they became adolescents, okay? Observation here, less delinquency, higher rates of high school graduation, higher rates of employment following high school. Okay? So the curriculum for the program was especially designed to provide a wide variety of stimulus inputs without overwhelming the child. So, that is what that that is following Hunt's notion, okay, and then Head Start of course began in 1965, designed to enrich the environment for children from low socioeconomic families. Now, as you see that it was cut when when in the U.S. Okay, it was cut when the Republican took the Congress, but then when the Democrat regained control of the Congress, it was reinstated. But I think Trump cut it, and now it is it seems that the Republicans in the United States, okay, they dislike this program. Why? Because most of the children in the Head Start program, they are They are 3-4 years old, black kids from impoverished neighborhoods. Talk about discrimination, right? Alright, so let's take a look at the first 3 years of life, the importance of the first 3 years of life. Okay? Burton White, Stanford psychologist, in 1975, he published a book, okay, with that name, the first 3 years of life. Okay. Burton White is convinced that the critical period for psychological growth actually occurs during the 8 to 18 months age period. If you read the book, I read the book twice. The first time before my first child was born. But then after he was born, I read the book the second time. Then I understood a lot, far better than the first time. Okay, I urge you to read it because it has revisions or new editions. Okay, very well written. Okay, all right. So critical period. Critical period for psychological growth occurs during the first 8 to 18 months. Okay, so growth during the first 8 months of life seems to take care of itself. That is to say, heavily influenced by biological factors and genetics. Little can be done either to arrest or facilitate the growth process. So that is to say, during the first 8 months of life, you see not a lot, okay, but make sure that you feed the baby well, and that the baby will grow. Okay, environmental encounters here become critical from 8 to 18 months. So the mother's role or the primary caretaker's role becomes very important. So Burton White believes the real key to sound growth is the quality of the child's interpersonal exchanges with the mother or the primary caretaker. So the interpersonal exchange, okay? And then Burton White suggests that the mother should encourage a child to adopt a certain amount of competitiveness, and that this is best done in a non-threatening context. Now, I will explain all this here. Okay, all this here, giving you examples. All right. Now, in order to raise psychologically competent children, White suggests that parents must be trained to excel in 3 key roles during the critical 8 to 18 month period. First, as designer and organizer of the child's physical environment. Okay, so What does that mean? Well, physical environment, remember Hans one, stimulus variety. See, the baby lying in a crib all the time, okay? You should what? Say, when the baby is awake, the baby will look around. Say, why mention what? What? The best thing, the best toys, okay? The best toys would be what? The best toy would be a mirror, okay? At the side of the crib. So when the baby when the baby wakes up, the baby will look sideward and what? The baby will see what? See herself, see himself. Okay? And the baby will spend lots of time staring at the mirror. Okay, so that provides what? Visual stimulation. Then what? The wall put what? Put posters. Okay, of course big because what? Remember vision, the child vision. Okay, big poster, and then you change them from time to time. Say every 3 weeks you change them, put a different one here, different one here, different one there. Okay, that type of thing. All right. So that's the first. And second, as authorities who set limits to dangerous or annoying behavior. So you have to stop the baby from what? Crawling towards what? The stairs leading down to the basement, all right? That type of thing. And third, as consultants to the child in brief episodes according to need. As consultant, and say you advise the child, no, you don't do this, you do that, that type of thing. Anyway, so Burton White, he sees what? He sees that what? Several things. I'm going to talk about that in detail. So let's say the crib toys. Mirror is good. Okay, mirror is good. He observed the following. Parent put what? The crib toys. The baby is here, sleeping here, looking upward. The crib toys hanging above what? The baby. Okay. Now, most of the crib toys at that time, even now, okay, when adults look at the toy, oh, this is beautiful because the crib toy hanging here. Then what? You see here, the adult will see it from here. It is beautiful. But imagine the baby lying down here will only see this. This is not interesting. Is that right? This is absolutely not interesting. So, Burton White, he observed this. So he developed a line of toys called the Playtential. Okay? The crib toy is not like this, but then what? It is like this here. So when the baby looks at the crib toy, the baby could see the beautiful figure here. Okay, not like this. This is not interesting. Let's say Cinderella, beautiful Cinderella. Cinderella, this is the one. No, this is the sole of Cinderella's shoes. This, oh, beautiful Cinderella. Is that right? So the potential toys, they are all like this. But then when it is hanging in the toy shop here, parents look at them. What is it? Okay, what is it? That type of thing. So potential existed for, I remember, 3 to 5 years because parents were not interested in his stupid parents, all right? So that it went belly up, potential. And but then what? So that's crib toys. Say when the baby could walk, could crawl, or could walk, the best toy suggested by Burton White would be just a round ball. Balls of different sizes, okay? Because what? When the ball is rolling on the floor, you could not predict the direction of the baby because they hit the wall and then bounce here and there, that type of thing, all right? Okay, now, he suggested here breast milk is the best for the baby. Okay? When I was doing my PhD at the University of Toronto, I analyzed data for a Department of Nutritional Science. That was what 1979, 1980, and at that time the lab, because I analyzed all the amino acid from the breast milk, compared that with formula milk, and then we already knew 100% that breast milk was much better than formula in every aspect. Okay, we analyzed many amino acids in the gas chromatograph. Okay, so I analyzed all the data statistically. Okay, anyway, so breast milk breast milk is much better because the sense of touch, which serves to relax the body and mind of both the mother and the child. Okay, it also reduces blood pressure. Okay, so the sense of touch is very important to the baby, to the mother, and of course here for a loving couple, the touching is very important, right? And then because when the mother holds the baby skin to skin, it helps. And then of course, feeding the baby with breast milk, it helps to shrink the uterus. A very recent finding, but Burton White suggested that breast milk is good. It also, we know now that breast milk helps build up the baby's immune system. All right? So you see here, touching the benefit of breast milk, all researched by Burton White. All right? Now, by 2.5 to 3 years old, social interaction becomes the focus of the toddlers. They like to play, of course, all toddlers, they like to play. I like to play too, and you too, I believe you too, okay? It's time for early schooling or nursery, because when the child is ripe for social interaction. But then social interaction with just the primary caretakers, not enough. Okay? So the parents will quickly find that the baby wants to play with its peers, okay, with other babies. Okay, so it's time to invite friends in, or times to say at 3 years old, time to send the baby to nursery school. Okay, but then of course here, if parents could afford it. Okay, now one thing that Burton White pointed out is called between the age of 2.5 to about 4 years old, the child is a very it's difficult to deal with. This is a stage called negativism. Negativism means at that time the child after 2 years old, the child has mastered walking, so the child would experience explosion of language, and because of language, the child understands the word I, me, ha, this is me. Okay. Well, they have the first experience of self-identity. So you don't tell me what to do. I do what I want to do. So that's negativism. That is one. In English, there's a term called horrible three or horrible four. Okay? So the child will not listen to the parents. Okay? No, don't do this, the child will do that. Okay? Don't go there, the child will do that. I'm me. I want to go there. So, okay, that's negativism. Very difficult to deal with. Okay? Go to bed now, it's bedtime. No. Eat it is good for you. No. Okay, the doctor no. That's negativism. But then if you slap the child, that's not good. Okay, you should negotiate with the child. Try to be nice, and then of course what is very difficult to deal with is a frustrating one. Frustrating period for parents or primary caretaker. All right, so that was negativism at what got a horrible free, okay, at that time. So we have to understand this, okay. But then after this period, then the child becomes what? An angel. Very nice. You will love it. Okay. From what? From about 4 years old to what? 12 years old. Okay. The child is an angel. Okay. After 12, I don't know. Some of them will become a beast. I'll come to that later on. Okay. Anyway, now negativism for human being, there are 3 stages. The first one, horrible free. Okay. For most of us, we went through this. For adolescents around 16 to 18, that's a rebellious stage, is that right? Adolescents like what? Adolescents what? Begin to what? To leave home, begin to have what? To have arguments with parents, okay? And they begin to have friends outside of home, okay? The friends, okay? They are like magnets, okay? And then the other lesson is also a magnet, so it attracts them, okay? So this is the home attachment to the parents has weakened a lot. Then attachment to friends outside of the home becomes much stronger. So they hang around with friends at the corner store and so on. So this is a very important age that we all I think we all went through. Most of you must have gone through this stage, okay? Or some of you are even at this stage, is that right? Anyway, it's called the rebellious stage. And then the third negativism occurs for women at the menopause. Okay? Menopause tends to change change the woman's physical appearance, and it may also change the woman's personality. For men, it is called the middle-age crazy. Okay? Have you seen? There are several films on middle-age crazy that is say the old man about 50 years old tried to prove to the world that he could still do it, he could still be strong. So he wanted to go out and buy a Porsche, okay, and drives around, try to attract beautiful women, that kind of thing, okay, middle-age craziness, okay. So that is the final stage of negativism. Most human beings, we go through these 3 stages of negativism. Okay, of course, and if we could find a way to deal with it positively, we will come out to become more mature. Okay, all right. So that's Burton White. Okay, I urge you, especially those expecting parents, read the book. Okay, and you will be you will gain a lot. Okay, thank you.